So this is the experiment number 4, AC voltage controller using DIAC TRIAC combination. The circuit is rigged up according to the circuit diagram given in the manual. Here you are supposed to connect one 0.22 microfarad across the circuit between this ground point and the DIAC to TRIAC connection. Okay. And you have to use two channels. One is across this one, this CRO, and the other one is across the TRIAC. One more channel, it has to be connected to the CRO here. Okay, you have to vary the alpha and beta values by varying this resistor. This is called as a firing angle. So firing angle can be adjusted by using this knob. See, when I rotate this knob towards left side and right side, so the signal is varying here. You can just observe. So this is the first channel obtained across this CRO. Okay. Now if I want to have both the channels, I'll connect one more channel. Yeah. So this is the other signal what you got it from the output of the TRIAC. See, this is your square wave signal. Okay. So this from the output of the TRIAC, just you have to measure the amplitude, but not the alpha and beta. But if you want to measure the alpha and beta, you can just remove this channel. Then you can measure only with this waveform, this characteristics alpha and beta. So alpha value is from, I'll show you from with the help of the waveform, from this point to this point. Okay, that is on period. So this is your alpha value, this is your beta value from here to here. The total angle between this alpha and beta, you are going to have it as a 180 degrees. Okay, so alpha can be measured. Either you can measure the beta value or you can measure the alpha value. You just reduce by the 180 degrees. Then you will get a theoretical, this practical value of this alpha and beta of DIAC and TRIAC. So now this is your tabular column. What you are supposed to note down the readings of alpha, beta. Got it? Okay. Then according to this circuit, what we have achieved, we are going to note down these values. So how we have calculated for alpha and beta here. So you have to measure how many divisions are taken for alpha. Then you have to find out how many divisions are present for 180 degrees. Then for 180 degrees, how many divisions you have got it for alpha, that has to be multiplied here. So 4 into 12. So one division you are going to got it. You have received as a you have got it as a 12 degrees. So for alpha you got it as a 4 divisions. That has to be multiplied by 12. You are going to get it as a 48 degrees. So that lies for the range of less than 90 degrees of alpha value. So you are supposed to do two cases. One is a less than 90 degrees. The other one is a greater than 90 degrees. So when you alter this firing angle, this knob, you are going to achieve for greater than 90 degrees as well as for less than 90 degrees. You measure how many divisions it has been taken for measuring alpha and beta. Okay, so here you got it as for alpha greater than 90 degrees, that is 108 degrees. For this less than 90 degrees. Okay, so commonly you measure what is the output voltage received at the output of the TRIAC. Okay, that we have achieved as 0.8. So that doesn't matter, whatever it may be, it will be common for both the channels. Okay, that amplitude is the common for both the channels. You are supposed to note down these values and all clearly. Okay.